So following that up, I'm Penina Kessler. I'm a software engineer at X.AI, and I work primarily on our response and decision-making system. So I'm going to talk about sort of the applications of data science and what our product actually does after we've resolved the natural language challenge. But I'm also going to discuss how there's a lot of ambiguity in natural language in and of itself. So X.AI is an artificial intelligence startup based here in New York City that makes a product that does one thing and exactly one thing. And that thing is schedule meetings for you. So our products, Amy or Andrew, should you prefer, I only use Andrew, handle your calendar. So in this example, you see a meeting request is made. Someone asks, hey, can you meet up next week? Here's a range of times that I'm available. And the way we think about scheduling a meeting at X.AI is that it's sort of a game of ping pong. You go back and forth about what times you're available, what locations work for you, anyone else who needs to be added to the meeting. And finally, if you can reach a consensus on an available time, a good location, everyone who needs to be there can make it, you send out an invite. So what our product does is when you CC it into the meeting, it takes over that negotiation for you. And ideally, you end up with the invite on your calendar and no additional work on your part. So what this sort of looks like from an email visualization sense is someone, say, likes my talk here, wants to meet up. I CC in Amy, or really Andrew, and Andrew takes off. He knows the hours that I'm available. He knows where I like to get coffee. And he tells you, these are the times that work. These are the times maybe that don't. And do any of these work for you? And ideally, we end up with coffee on, I'm guessing this is November 7th, and everything works out. So the key points that I want you to take away from this talk is what X.AI uses Scala for. So we use Scala throughout our different applications, in our data science, in our decision-making engine, and in our response system as well. So in the part of the system that actually generates emails back to the user. And why we feel it's important to use Scala versus another programming language is that Scala gives us a lot of flexibility, but also safety to sound a little bit more human than the average chatbot. So you have horizontal AIs like Siri and Alexa who can perform a task for you and sort of respond, and then you have chatbots whose sole purpose is just to respond to your actions. Our agents are a little different. They do one thing. And because they only do one thing, they're not going to go back and forth with you if you ask them, hey, what's the weather like? Or tell me the score of the Vikings game. And we are really proud of that. We want to focus on one thing and getting that one thing right. And in order to do that, we sort of have to think a couple steps ahead of the user. So from a game of ping pong, it goes to a little bit like a game of chess. We're thinking 2 emails ahead. Okay, if I say this, then you'll take this action, and then I can send out the invite. So the 3 challenges that we think of when building our products are its ability to read. So like a human, we need to interpret natural language. Our agents work only over email. We're thinking about Slack integration. It's coming. And it works sort of to parse out the things that are relevant to the meeting from anything else in the email. So the niceties, the signature. We really try to extract only the bits that we feel are important to scheduling the meeting. The reasoning behind our brain application is pretty nuanced, and that's a huge part of what I'll be discussing today. But we really try to focus it on what action do we need to take to move the dialogue forward. And our responding, which strives to be as natural and as human-like as possible. So the best compliment we actually get from people is, "Oh, I thought Amy was human." So the way I like to conceptualize our response system, and this might just be because I have a background in cognitive psychology, is it's sort of like our brain, or it sort of mimics a lot of our brain-like processes. So here you see there's an incoming soccer ball, and the goalie sees the stimulus. And like our brain, it breaks it down into the parts that are important and reassembles that into the brain language. It takes it from those rays of light and reassembles it in our brain as brain waves. And then at that point where we realize, hey, there's a soccer ball coming at my face, we have to act. We have to make a decision, because this has important implications, at least in the real world, for our survival and evolution, everything like that. Thankfully, Amy and Andrew only have to schedule meetings. But we really have to take in a lot of stimuli all at once and break them down into what's the most important bit, and then think about, okay, what do I and should I do next? So the way Amy and Andrew's brain works is actually pretty similar. An email comes in, this is the stimulus part, and from there, our data science predictors get to work on classifying the things that are important. So any people mentioned who seem like they're going to be relevant to the meeting, any times, any locations. There's a lot of ambiguity there that we need to resolve. Is June who is mentioned in the body of this email, is that a month or is that a person? And then once we've extracted sort of everything we need from the body of the email, we put it in context. So we think about that coffee that was mentioned in terms of, where does Penina like to take coffee? Where has she told me before that she likes to take coffee? Or when she says next week, does she really just mean Monday through Wednesday, because Thursday and Friday are blocked off on her calendar? And sort of stripping away that layer of social nicety that you put into an email when you're, say, meeting up with someone you don't know that well, and interpreting it into what actually works for that user. And once we've computed what actually works, we have to then tell people, this is what we know about the meeting, this is what we know works. So this is a Sankey diagram, which is a tool for data visualization. So to go back to the ping pong metaphor, our goal at X.AI is really to make that game of ping pong as short as possible. We want to shorten the length of our email thread so that while our users are hopefully experiencing a lot less pain in terms of sending emails back and forth, we also want to shorten that dialogue with their guests. We want to propose the best times for the guest and the best location. So the top part of the diagram represents what we consider the ideal thread. A meeting request comes in, the agent proposes some times, the guest confirms, we propose a location, the guest confirms, we send out an invite. But as you can see from the bottom, there's a lot of entropy that could happen. There's a lot of different paths that that dialogue can take, and we need to be prepared to predict what happens next and also predict the next best action. So say the original times we proposed in that little red bar didn't actually work for the guest. We need to think, okay, based on what you just told me about your availability, what's the next best time that also works with this customer's calendar? So our reading, our NLU, or natural language understanding, takes similarly to the way our brain takes the sort of data and stimuli that come in from our senses and interprets it into brain language. We take the human language and interpret it into our machine language, our data models. So we pick out the parts of the email that are actionable, but we also attribute sentiment to that email. If you're telling me, hey, does 3 p.m. work instead? That agent needs to understand that not only is 3 p.m. referring to 3 p.m. next Monday, but also that it's a time that's available for this user. So there's a decent amount of sentiment analysis and ambiguity resolution that needs to occur to resolve it to a singular point in time, and then pass the intention of that email to the brain-making application. The brain-like application infers based on the context what action to take next. So if in the middle of a dialogue we get the email, hey, does 3 p.m. work instead? The action that the broker or the agent is supposed to take is actually very different based on what happened previously. So if we proposed 2 p.m., and that was the first email we ever sent you, we said, hey, does 2 p.m. work? And you come back and say, hey, does 3 p.m. work instead? All the agent needs to do is check the customer's calendar, see if 3 p.m. is available, and either confirm or decline that time. But if, say, the last email that we sent to that participant was an ICS invite, so we scheduled a meeting, and we scheduled that meeting for 2 p.m., we then need to go and check that time against the user's calendar, but then also understand that, hey, does 3 p.m. work instead, as an implicit request to reschedule the entire time of the meeting. And based on that, we then need to go out and tell all of the other participants of the meeting, hey, this other person can't make 2 p.m. Is 3 p.m. good for you? So a couple of reasons why we chose to use Scala to build in all of this decision making. The biggest one that I think any developer at X.AI will tell you is type safety. So Scala, being such a strongly typed language, allows us to sort of fact check our assumptions at compile time rather than in production. If we're computing something and we're expecting a type of, say, reschedule response to come back, and what we get back isn't that, we'll know immediately that that part of the application is not working as expected. We also do a lot of this type checking in our machine learning. There's a typeless open source project on GitHub, if any of you want to check it out, that actually does the same things for our feature generators. So if our feature generator is using something it shouldn't, we'll know that again at compile time rather than in production. And finally, we think of all of these different types of responses as things that need to be computed functionally. So each type of response gets computed in its own independent part of the application. And functional programming in Scala allows us to reason between these different responses and sort of interpret the hierarchy of responses in a type-safe and also dynamic way. So when we get to the time of sending a response, we take those homemade, homegrown types and send them to our response building application, and as well as some functions from being able to parse them from that temporal model that resolved 3 p.m. to next Monday to back into a human readable format. We have a wonderful AI interaction designer, Diane, who could not be here tonight, who then has written a set of templates that get dynamically generated at runtime to decide what the messaging to our customer and their guests should look like. So who gets told what at the moment where the emails need to be sent out. And we pass a great deal of context from the decision-making application to our templates so that they're almost mini decision-making applications in and of themselves. They decide who gets told what based on what we previously told that person in the thread. So we feel that it's very important to pass in a lot of context and sort of build in a lot of humanity to our agent. The next slide will hopefully help you guys understand why. So we have a lot of different kinds of validation on our response output in addition to our type-safe checks. We have integration and regression testing in Scala. There's another open source library called, I think it's just called diff, that helps you actually visualize the difference in your output. So you can compare two versions of the application against one another and visualize the difference in all of the data structures and all of the responses that get passed on to the user. Our interaction designer has also produced both a whitelist and a blacklist of acceptable response combinations. So it wouldn't really make sense to say, hey, can you meet next Tuesday at 3 if, say, the meeting was about to be canceled, or if the last email we'd gotten said, hey, this meeting is canceled. So based on that, if something illogical were to occur in the application, we would actually trim down the response until it met the whitelisted criteria. And finally, all of the context that we pass on through the application helps us, we believe, humanize the agent. So if I asked Alexa in 3 different ways what the weather was like, and she told me the exact same answer, but I had asked her, what's the weather like on Tuesday, what's the weather like on Wednesday, and what's the weather like on Thursday, I would maybe think that she was broken. And we sort of take the same approach to Amy and Andrew. If you ask us a different question and we give you the same response, we think that that's maybe not the best interaction for you as a human to take with a machine. So the column on the left is what our response would look like if you proposed, say, 3 different times, and we just came back every time saying, I'm sorry, that's not available. The column on the, oh, sorry, my left, your right. The column on my right, your left, is what it actually looks like in our templates, where we slightly tweak the wording based on what we previously sent to the sender. So if we've previously declined a time to you and said, I'm sorry, this customer is not available, the next time we'll apologize for it. We'll sort of take that extra step of knowing this must be a frustrating experience for you. And if we've already had to do that twice, we'll go the extra mile. We'll say, I'm so sorry. So I hope that you guys have gotten a good picture of X.AI and the different applications of Scala in our system. Should you like what I've talked about and want to work with us, we are hiring. Should you want to challenge me on anything I said, that's my Twitter handle. I don't check it that often, so that would be great. You can also reach out to me at Penina@human or X.AI as a company on Twitter. Yeah?
Did you use any particular library for the parsing of natural language?
We use Stanford, but a data scientist would be able to tell you a lot more. Yeah.
So when somebody becomes really frustrated that you cannot give them the time of the meeting and like curse at Amy, what do you do?
So we actually have a bunch of different sort of responses built in depending on what you say. If you swear at Amy, she will probably shut down, in that she will forward your message onto the customer and say, your guest has treated me rudely, or your guest clearly does not want to work with me. I'm not going to schedule this meeting unless you tell me otherwise. But we also definitely try to mitigate that sort of frustration so that no one becomes that enraged with the artificial intelligence.
You might get towards like a few attempts kind of like a huge group of people, like say you have 200 people or something like that, and then you need to kind of then cut out people, like say only try to find like the maximum number of people you can make it.
So we're focused right now on scheduling smaller group meetings. The number grows larger the more people who are customers. So internally, we all have accounts, we all have our calendars hooked up, so scheduling is a breeze. But right now we're focused on solving small group meetings, so the maximum number of people external to your company who you can schedule with, if none of them are customers, is 4.
How are you scaling this? Are you using like an actor-based model like Akka or something? How are you implementing this approach?
Akka. Yeah.
Will Andrew or Amy's tone shift based on the tone of the conversation between the two people being in the conversation?
So no, which is both good and bad. I think that if you're rescheduling a meeting for the 10th time and you're sort of trying to blow someone off without blowing them off, you really do want that AI touch of they're just going to say the exact same thing to you, no matter if they're rescheduling for the first time or the 10th time. They're just going to try to get the job done. That said, we do try to tell our users that it's really all in the way you queue in the agent. So if you're saying, I'm going to blow you off, here's my bot, go talk to Andrew or Amy, that's a much more frustrating experience on the guest side immediately. Whereas if you're saying, hey, I'm so sorry, Amy's going to handle it from here, you've sort of cushioned the blow.
Does Amy have a sense of who the most important person in the meeting is?
So yes and no. It really depends on what you tell her. So if you tell her, hey, schedule this meeting with Catherine, but it's okay if Joe can't make it, then she'll primarily negotiate with Catherine, and Joe will get the invite, and if Joe doesn't show up, that's fine. But she won't say Taylor, unless you explicitly cue her to say, hey, this person is not essential to this meeting, she'll treat everyone as equally essential. So it's sort of equalizing and also maybe not nuanced in the same way.
Yeah, just to follow up, I mean, is there a concept like this person is indispensable? If this person doesn't show up, then the meeting is no use.
So we try to treat all of our guests as indispensable. If no, but we also have, so we have a lot of logic built in of like how many times we'll follow up with someone before we'll give up on the meeting, but then also how many people have to respond before we'll cancel the meeting. So if one person hasn't responded and 2 other people have and they've confirmed a time, we're just going to go ahead and schedule without that third person. But if 3 people haven't responded and 1 person has, unless that person was explicitly marked as sort of the most important person in the meeting, we would cancel that meeting. But if you say, like, schedule a meeting with Catherine, and sort of only Catherine is important to the meeting, Amy and Andrew will pick up on that. Yeah?
How does it handle rescheduling?
You just tell it you need to reschedule.
I mean, if I let's say I have prior appointments, right?
Mm-hmm.
I have a priority meeting. I just tell it to you.
So we try very, very hard not to double book you. So Amy and Andrew will never schedule over another meeting that they've already booked for you. And they'll never schedule over another external meeting on your calendar unless you explicitly tell them to schedule for that time. And in that event, they'll send you a little pushback email to say, hey, I see you have this other meeting. Are you absolutely sure you want me to use this time? Yeah.
What happens when Amy or Andrew winds up negotiating with another Amy or Andrew?
So that's actually what we call scheduling nirvana, which is a term that Dennis Mortensen coined. I can't take credit for it. But all of that logic lies in the brain application, and it's actually a very seamless experience because we don't have to negotiate those times with another participant. We don't need to say, ask your guest for their phone number. We should already have that information on file.
So it just resolves immediately?
Yeah. So like if you were a customer and you were like, hey, let's meet next week, Amy wouldn't even reach out to me to propose time. She'd just be like, hey, here's this meeting.
Is there a number set for the responses? Like keep negotiating until their point of time?
So they negotiate 24/7, 365, which is maybe not the way humans operate. I personally don't try to check my work email on the weekend, but as long as the guests seem like willing participants, so as long as they're responsive, Amy and Andrew will work their hardest to drive that meeting to completion. So they are very sort of singularly focused on, let's get this meeting on the calendar. Yeah, there's no limit to the amount of emails they'll send. Like you could schedule and reschedule an email for a year, or a meeting for a year, and they would still work it every single time. Yeah?
What's like the median number of back and forth it takes to schedule?
So I think we did some internal study, and we found that the ideal number was 8, including the invite. So 8 emails back and forth from the email initiating the meeting to the ICS email.
Like including the responded email?
Yeah.
I think the other day I heard the gentleman mention that you had about 100 people training the models. Did I mishear that? Was it accurate?
So we do what we call supervised learning. So should our predictors not be able to predict with a certain interval of confidence that June is a person or a month, it'll get kicked back for human supervision. I can't speak to the exact figure of people supervising, but if Dennis said it, Dennis probably knows better than I do.
Is this being used
In
real life?
in real life, sure. Do you want a free trial?